This detailed example deals with the chi-squared test, and we're going to use a random sample of 20 cases from the 2012 General Social Survey. So suppose that we wanted to look at the relationship between health and happiness. If we looked at it for this sample of only 20 cases, we can't be sure that whatever relationship we find in this sample will also hold in the larger population. And so we have to conduct the chi-square test to see if the relationship that we find for this sample of 20 cases also holds in the larger population of GSS respondents from which the sample was drawn. And so we can first start by basically just hiding all the variables that we aren't going to use in this example. And that leaves us with just two variables, health and happiness. And so let's create a bivariate frequency table using a pivot table. So we'll go to Insert, Pivot Table, and let's put this in the existing worksheet. And we're going to make health our independent variable. And so its values are going to go down the columns. Happiness is going to be our dependent variable. Its values are going to go down the rows. And we want basically the values of happy, and we want to get their count. Now, just to get rid of some of the formatting that Excel puts in, let's copy this table and paste over it by going to Home, Paste Values. That way, this is a little bit easier to work with. And so notice that this one cell is empty, so that means it has a 0 value. Let's edit this just a little bit to make it a little bit more readable. First of all, let's get rid of the word grand so that we know that these are just totals. And we'll do that for both the row total and the column total. And let's put in the actual value labels for the variables. So this is the first category of health. These are actually people who are in excellent health. 2 for health is people who are in good health. And then 3 is people who are in fair health. And for happiness, code 1 is very happy, and code 2 is pretty happy. So now we can just resize some of these cells. We can either doing that by putting the cursor in between the cells and double-clicking, or we can just drag. Either way, we get the accomplished result. And if we wanted to, we could just kind of center align these values so that they are a little bit easier to read. We could do the same thing with these value labels. Okay, so we have our bivariate frequency table of health as an independent variable and happiness as a dependent variable. Now let's take a look at how to calculate our chi-square statistic. And so we have to use the following formula. The formula tells us that the chi-square statistic is equal to the sum across all cells of the difference between the observed frequency, which is the values that we just created in our table, and the expected frequencies, which we'll calculate in a second, squared divided by the expected frequencies. And our statistic follows the following degrees of freedom. We have to take the number of rows, r, and subtract 1, and multiply it by the number of columns, subtracting 1. Okay, so now let's calculate our expected frequencies. So if we go back to our Excel file, if these are our observed frequencies, we need a comparable table like this one that has expected frequencies. And so let's just take and copy and paste this whole thing, and we're going to create a table of expected frequencies. And so we don't need the observed frequencies anymore. We can delete those. And we calculate expected frequencies in the following way. What we do is we take the row marginal, and then we multiply it by the column marginal, and we divide that value by the total number of cases. And we're going to do that for every cell. So for this cell, we're going to take row marginal, multiply it by the column marginal, and divide it by the total number of cases. So again, row marginal, make sure you put it in parentheses because otherwise it'll throw off the calculations. Row marginal times column marginal divided by total number of cases. And we're going to do this every time. So we go down to the next row, and we have, again, row marginal times column marginal divided by the total number of cases. And same thing for all of them. Row marginal times column marginal divided by total number of cases. Row marginal, making sure to put in parentheses every time. Row marginal times column marginal divided by the total number of cases. Okay, so here's our table of expected values. Now what we can do is we can basically write out for every cell, side by side, the expected value and the observed value. So let's start with the observed frequencies. Let's call those FO. And so we're just going to use the equal sign to carry each of these over. So let's start with this one. We can center that if we want to. So here's our first one. This will be our next one. And this will be our next one. And then we'll go down to the next row for this one. And then this one. And then this one. Until we've got all of our cells. And we only have 6 cells here. So we're going to do the same thing for our expected cell frequencies. Let's call those F sub E. Now we have to make sure that we match the corresponding observed and expected frequency. So for this cell, the expected frequency is going to be this one. So that's going to be equal to this. For this cell, the corresponding one is this one. And so that's going to be equal to this one. And so on. I'm going to do the same thing I just did, using the same order, matching the expected frequencies and the observed frequencies. Okay, the next step is to take the difference between the observed frequencies and the expected frequencies. And so basically, I'm just going to subtract the values in this column from the values in this column. And I'm going to do that across all of the different cells. And so if I just put my cursor in the bottom right-hand corner of the cell and drag it down, it'll do the calculation for each of the cells. The next step basically is to take this difference and square it. And so I'm just going to basically take this and put in parentheses, put a little 2 and make my 2 a superscript. That gives me a heading. I can center align this if I want to. So it's just going to be basically equal to this value squared. And I'm going to, again, drag this formula down and do this for every case. And then what I have to do, basically, is just to take these values and divide them by the expected frequencies. And so for my heading, I'm going to take my difference between observed and expected frequencies squared and divide them by the expected frequencies. And I'm going to do that for every cell. And so that's going to be equal to this value divided by this value for this cell. And I'm going to do that for every cell. So now if I take the sum of the values using the equal sign of each of these cell columns, that's going to give me my chi-square statistic. And so in this case, my chi-square statistic is 1.665. Now, incidentally, if you want to check your work a little bit, you should find that your observed frequencies minus your expected frequencies equals 0. And so if we just take the sum of these values, they should sum to 0. So we know at least at this point that we've done the calculations correctly. And so we basically got a sum of 1.665, and that's our chi-square value. So now that we've found our chi-square statistic, or our chi-square obtained, we actually have to conduct the chi-square test. And so we have to compare our chi-square statistic to the chi-square critical value. And so how do we find the chi-square critical value? Well, if we go back to our formula, we see that we have to first calculate our degrees of freedom. So our chi-square statistic follows a chi-square distribution with degrees of freedom that are equal to the number of rows, which in our case is 2 minus 1, which gives us 1, times the number of columns, which in our case was 3, minus 1 gives us 2. So we're going to calculate the degrees of freedom as 1 times 2, and that's going to give us 2 degrees of freedom. And so we have to look up a chi-square value that's equal to 2 degrees of freedom, and we need to use an alpha level. Let's just use a conventional alpha level of 0.05. And so if we go to the chi-square table, the chi-square critical value for 2 degrees of freedom 0.05 alpha level is 5.99. And so you can see that our chi-square obtained is less than our critical value. And so we cannot reject the null hypothesis. And in this case, the null hypothesis is that the variables are not associated in the population. And so we can't rule out the idea that these two variables are actually not associated. And so whatever relationship we find between health and happiness in this case is probably due to sampling fluctuations. And so in the population, we have no evidence that there's a relationship between health and happiness. Now, one caution, we have a pretty small sample size of only 20 cases. And so it turns out that the chi-square test statistic is actually susceptible to small cases. And so if we use the larger sample size, we might find a value that's actually more significant. Another problem with the chi-square statistic is that it's very susceptible to small expected values. And we can see that here, this one has actually a very small expected value. So that could throw off the chi-square statistic in this case. So although we conclude that there's no relationship between the two variables in the population, we have to keep in mind that we have a small sample, which makes the chi-square statistic less likely to be significant. And we actually have some very small expected frequencies, which could make the statistic unstable. So we should use some caution when we're doing this test, given that we have such a small sample.